Next, the Gaussian filter, Gaussian blur or Gaussian filter, whatever you call, smoothens an image by averaging neighboring pixels. Here, image will completely be smoothened by taking the average of the neighboring pixels as we discussed earlier. This is called a Gaussian blur. So then, it is going to completely reduce the high frequency noise. If there is a high frequency, there will be white patch comes on the picture. That white patch can completely be reduced, right after which the image will completely be smoothened. Okay, next is the bilateral filter. In bilateral filter, what's going to happen? It is going to remove the noise while preserving the edges. Now the thing is, when you remove the noise, the biggest problem is the edges will be erased. For example, here, the structure of a human should not get erased. It should sustain, it should retain the actual features, right? Such as edges and the nose and eyes, everything should actually be preserved. Now, by using the bilateral, we will be able to remove the noise by preserving the, right after which, by making sure that edges will actually be preserved. Next thing is wavelet transform. What is wavelet transform? The entire picture will be decomposed into smaller segments and will be able to identify the errors, that will be able to identify the noise correctly if you divide into the segments. This is how the total decompose the image into multiple scales, filter the noise at the different levels. At each level, noise will be filtered. Right after you adjoin it, right after then if you adjoin it, you will be able to get a complete picture. Advanced time series techniques. What is the time series technique? Time series technique meaning will be applicable on the time series data. What is the time series data? Time series data is the data that is going to get collected in a specific time interval, such as weather forecasting or share prediction or temperature or heartbeat or whatever. This is called the time series. Now, time series techniques is something called a Kalman filter. Here, time series techniques are prone to a lot of errors because it just in time series there may be a lot of errors. At some point the graph goes higher, at some point the graph goes lower, and at the same time some point graph goes consistently. At some point the previous data will affect the future data. There are a lot of inconsistencies in the time series data. To handle that, there is something called a Kalman filter. It predicts the current state by the system and corrects the noise in the dynamic system. So it just makes the Kalman filter. In a simple terms, the Kalman filter is going to make the data consistent, because the biggest problem with the time series data is, for example, traffic flow. In the traffic flow, sometimes there will be high frequency, sometimes there will be low frequency. The rest of all the times, that there will be less frequency. So, in predicting what is the future traffic, these inconsistencies will the biggest problem. So, when you apply the Kalman filter, it just is going to exactly predict the current state. It will also be able to predict the future state. And there is also something called Savitzky-Golexy filter, fits successive segments of the signal to low degree polynomials for smoothing. And now, it is going to get successive segments of the signal. The consecutive segments of the signal will be collected, will be analyzed, by which we'll be able to get the future prediction. And the domain specific techniques, there is something called a natural language processing. In the natural language processing is a technique to remove the inconsistencies in the text data. The biggest problem with the text data is there is a lot of noise. Here, in the natural language processing remove the stop words. Stop words is like what? The, like, is, right? And the, and, a and the, these are not going to contribute. Here, we just, in the natural language processing, it is going to get a specific keywords. But some keywords which actually are unnecessary, which doesn't contribute much to the data, will be removed. And the audio data is going to spectral subtraction filter out the background noise. There is something called a spectral subtraction. In the spectral subtraction, we'll be able to remove the background noise. There are a lot of wonderful previous songs, right? Older days songs. Now, the people are using spectral subtraction, in which background noise will completely be eliminated, because the recording techniques were not as sophisticated as the current days. So, although the older songs are very good, but those are noisy. So, reduce the noise, we will use something called the spectral subtraction. Thank you.